What's up, everybody? Welcome back to the channel. Since I'm actually uploading, since I'm not taking like a 5-day break, here's a new video. So in this video, we're gonna be talking about factoring polynomials, and we're also gonna be talking about factoring quadratics, mainly special cases, right? So now let's talk about polynomials. So polynomials are, if you don't know polynomials, this video is probably not for you, because this video you're gonna need to know what they are, because we're gonna be factoring them now, and I'm not really that good at explaining what polynomials are. So let's say we have a polynomial such as, this is the wrong pen, I want that one. Okay. Let's say we have a polynomial such as 10x squared plus 4 plus, no, sorry, is that supposed to be? Yeah, plus 4 plus 6x plus 15x cubed. So the first thing I want to do is for some people, it makes them easier to put this in polynomial standards, right? So you can put this as x squared plus 10x squared plus 6x plus 4. Now, whenever simplifying these, you want to look for factors, right? So so in this case, we're going to just do this in order. We're going to put this in the bracket and then that in the bracket. So let's start with this one. So let's see, 15x cubed, so I'm just going to write this down. Yeah, so whenever having this, we want to look for the most of something. So let's take a look for a common factor. The GCF of these two, greatest common factor, is going to be 5. Now, let's take a look at the exponents. So the greatest common exponent we have is the base of x to the power of 2. So you can just put x to the power of 2. But this is our greatest exponent wise. Like this is our biggest exponent and a common base as well for these two. And our greatest common factor is also 5, right? So then we can put these in parentheses, right? Then let's see. So how much did we take out of 15x cubed? So what is 5x squared times this to get that? So let's take a look here. So the 5 times 3 is 15. So we can put 3. Now, what times x? So x squared times blank equals x cubed. So now knowing that is just that, and then that x cubed is, we need to multiply one more x. We'll just add x here. I just want to get rid of that. I want to add x. Plus, what did we take out of here? Well, for common factor, we took out 2, right? So we can put 2. And then x squared, we're going to take x squared times blank. X squared times the blank equals x squared. Well, x squared times 1 equals x squared, because x squared is just x squared, right? So we can just leave 2 alone. That's the first one. Let's take a look at the second one. Put that right there. And that would be 6x plus 4. This is a little easier because you don't have exponents. I mean, you technically have 1 and 1, but still, doesn't really matter. Right, so the greatest common factor here is 2. And we only have one x, and x is an unknown value, and 4, there's only one x, and the coefficient of x is 6, right? And 4 doesn't have any x, so 4 isn't the coefficient of any variable or unknown value in this case, right? So that means we'll just leave 2 as it is. So 2 times blank equals 6x. So now knowing that 2 times 3 is 6, we can put 3. And then what what 2 times 3 gets you 6x. Well, knowing that 2 times 3 is 6, 2 times 3x is actually 6x. We can just add x plus 2 times 2 is 4. Obvious. Now we can put this together as 15x squared parentheses. Sorry, not 15x squared. 5x squared plus 3x plus 2 plus 3x plus 2. So now here's where some people might have a little trouble, and it's probably easy. So whenever we have something that looks like this, and also just to, if you want to make sure that these equal that, you can use the distributive property. So 5x squared times 3x equals 15x cubed, yada yada, so on, right? However, I already know this, right? Because I have paper here that makes sure that everything is right. So after we do this, we want to simplify even more because we can easily simplify this, right? So what we can do is, now if you look here, 3x plus 2, 3x plus 2, right? Same thing. If you simplify it as far as you can go for a polynomial, in this case, these brackets should be the same, so we can actually cancel 1 out, right? So this will turn into 3x plus 2 times, remember, you're not adding, you're actually multiplying. So whenever you're multiplying, well, you're going to multiply 5x squared times that, so you're going to add that here. You're going to multiply this by each of those two values, because in this case, you're multiplying that and that. Then you're also going to multiply 2 by this, because you're multiplying this and that, right? And we can even prove that this is actually accurate, because if you notice here, multiply that and that, you get this form. Multiply this and that, you would get this form, right? So that's how we know that. So in other words, 10x squared plus 4 plus 6x plus 15x cubed equals 3x plus 2, 5x squared plus 2. Basically what polynomials are. So that's how you would do it. Let's try another one. This is h squared plus 7h plus 7 plus h to the third. So let's put this in, of course, just to make it easier, we can put this in normal standards, right? So h plus h to the second plus 7h plus 7. So we're going to do this and that again. So this will just turn into, let's see. So knowing that we have h to the third plus h to the second, we have an h, right? Only h. Because the second can have 1, right? So we only have the greatest exponent with the same base, and the only base here is 2. That's the greatest thing. That's the greatest common exponent with the same base, which is actually h for this case. So then we multiply. So h squared times blank equals h to the third. Well, so this is, of course, h to the third equals that, right? However, h to the second just equals that. So we just need to multiply h. And then we can add plus 1, because h squared times 1 is just h squared alone, right? Okay, so now let's do this part. So, I'm moving a little faster because I already explained most of it here, and I don't want to waste your time, so go down right here. 7h plus 7. Greatest common factor is 7, and we only have one h, right? Because the coefficient of the only h is 7, and this doesn't even have an unknown variable for its coefficient, right? So we just turn into 7. 7 times blank equals 7h, so 7 times h will just equal 7h, plus 1, because 7 times 1 is going to be itself 7. Yeah, that's basically that. So now we can put these in together. H squared plus h plus 1 plus 7h plus 1. Right? Yeah, right. So now, based off what we just did, if you look at these two brackets, so these two parentheses, these multipliers, the parentheses that's going to be multiplied, the same thing, so we can cancel that one of them out. So this would just turn into h plus 1 multiplied by h squared times that, so that means h squared plus 7 times that. And just like I proved earlier, we can do that, a squared times that, and then 7 times 7 times 1 plus 7 times h. So that means h squared plus 7h plus 7 plus h to the third equals h plus 1 plus h squared plus 7. That's basically a simplified polynomials. Of course, they get a little more challenging, but this is just an introduction, because sometimes you might have negative numbers, yada yada, and I'm not going to introduce that. So let's continue. Here is where we're going to get into factoring, special cases, and quadratics. So we're going to be talking about, and this right here, and the rest, and I was going to show you them on this board. This right here is going to be coming out in a very big video. We're going to be working on a huge whiteboard. It's coming out this week, and I think I introduced it in the exponent video. I'm working on a new video about digging deeper into quadratics. And this right here is what we're going to be talking about. We're also going to be talking about calculus, like d over dx, function, yada yada. We're going to be proving that too. We're going to be proving the formula equation. I'm not going to get into too much of that. You just have to wait for the video. I promise you, it's going to be amazing. So I worked really hard for it. You get the point. Yeah, so this equals is something you might have to remember, and I'll actually prove that this equals that in the video too. Just as a heads up. This equals and then this equals. Now this isn't as important as these two. This two is something really important. You're going to be using quadratics all the time. This, you probably use it a good solid amount of times. These are so well-known formulas, and yeah. So let's do the first one. So let's look at, we have a squared plus b squared plus 2ab. So, as always, we're going to be working with the quadratic formula, right? We're going to be always working with this most of the time. So, in special cases, when you have this, let's say we have 15x squared plus 2x plus 3. You see, clearly in the form of that, we have 3 of this constant, 2x, the coefficient of x is b, and then the coefficient of x squared is 15. Or in other words, a in this case. Right? Now, if you notice here, this is actually written in a squared plus b squared plus 2ab. Right? So now we already know what our a is. Our a is 15, and our b is 2. Now, if you don't know how to do this, I will highly recommend watching the quadratics video. It just explains how to do this, really. If you don't know how to do that, I'd highly recommend watching that video. And knowing that we can put these values in there, right? So 15 squared plus 2 squared plus 2, 15, and what, b? Yeah, 2. Let's simplify this. 15 times 15, 225, plus 4, plus 2 times 15 is 30, 30 times 2 is 60. Right? Right. Actually, we don't really have to do. Yeah, we can simplify, I suppose. let's just simplify it, because why not? 64 plus 225. This equals 289. I don't know really why I simplified it, to be honest. We didn't really have to. Actually, I would highly recommend not. In some cases, you might want to simplify this. All we need to know is how to put this into that. And we just did that using that. Okay, so let's continue. What we're gonna do is put in the x squared plus bx plus c into what we're gonna be doing, right? So now let's do another one. So now we're gonna be putting a squared minus 2ab plus b squared, and this equals a minus b squared, right? So let's say we have 10x squared minus 5x plus 8. Let's say we have this, right? When we were to put this in that, well, if you notice here we have minus 5. So that's a good thing, because we shouldn't have negative b, right? Well, it doesn't really matter. I don't think it matters, and it probably doesn't matter, but I'm not sure. Anyway, we have this, so we can identify our a's. Our a is 10, and our b is negative 5, right? Now let's put it in that form. So a squared, 10 squared, sorry, I want to delete that. 10 squared minus 2 times 10 times negative 5 plus negative 5 squared. This equals 100 minus, negative 2. You can assume this as plus, and then we'll put this value in, right? Negative 2 times 10 is negative 20. Negative 20 times negative 5 is actually 100. Actually, I don't know why I'm simplifying this again, and this is 25. 200 plus 25 is 225. I don't know, I'm so used to simplifying this. You don't need to simplify this. All we're trying to do is put this quadratic formula into this type of form. Next, this is actually a much easier one. This should take 1 minute to explain. A squared minus b squared equals a minus b, a plus b. Right, so let's say we have, I don't know, this isn't really. A is 18x squared minus 5. Right? Actually, sorry, that wouldn't actually make sense. Minus 25. You're going to put this into that form. Oh no. Oh yeah, sorry. This should actually be just we want a perfect square here. Here's another example. Right, so now we'll put this in that form. Well, this is kind of easy. Minus 4, negative 4, so negative 2 squared, right? No, yeah. Minus 2 squared, and then this section might be wrong, I'm not sure. Then 5x squared. That's how you put this into that form. Kind of easy, nothing too worried. Anyway, that's basically what we're going to be doing this video. I hope you enjoyed that, actually. I had pretty fun making it, and I'll see you guys in the next one. And always,